Hi everyone, Mr. Boltri here bringing you video 6.4. We're going to be talking about the friction lab. So for the friction lab, we've been talking about friction all year and it's finally time for us to be able to quantify it. So as always, please pull out your lab notebook, turn to the next available page, and we can get our lab notebook all set up so we can dive right into the lab for our next class. So for this lab, we're going to be investigating the question, what is the relationship between force normal and force friction? And we can talk a little bit in class about why force normal is what changes force friction. But if you think about it, force friction is caused by the rubbing together of two surfaces. And force normal is a measure of how much the table is pushing up on the surface. So if it's pushing up, that's going to cause them to rub together more. So that's why we're looking at the relationship between force normal and force friction. So in this experiment, we are going to be experimenting with a wood block that is rubbing up against some surface. So different groups are going to get different surfaces, but you're going to have a wood block that is rubbing up against a surface. So to increase the force normal, we're going to add some masses on top. The more masses you have, the more force gravity pulls down, the more force normal has to push up, and the more those two surfaces are going to be squished together. When they're squished together, there might be some more rubbing, some more friction. To determine how much friction there is, we are going to have to attach a force sensor. And then we are going to pull the block using the force sensor via a string. And the motion detector is there to allow us to figure out when exactly the block starts to move. Because when the block starts to move, that's when we know the force sensor is pulling harder than the friction. Because as long as they're equal, then the forces are balanced. But as soon as the block moves, the forces become unbalanced. So we want to know that exact moment that the block starts to move so we can record the force then, because that's how we'll know how much force friction there is. So you can get some of the most important parts of this drawn down in your sketch, including the motion detector, so we can tell when the block starts to move, the block with masses stacked on top, and then we're going to pull with the force sensor attached to the string. So for the procedure, I'm going to ask that you write your own, making sure that you're clear about what you're measuring, when and how, and then what you're changing from one trial to the next. But to give you kind of a sense of what this experiment is going to look like, I'm going to show you a video of me doing one trial of the experiment. So there I am, and you can see that I have my wood block set up and my force sensor. So let's just look at it. I'm going to start my Logger Pro. And then I'm going to pull very gently on the wood block right until I see the block move. When I see the block move, that's when I know the force is greater than the force friction. And then I can reset it. And you'll notice I didn't add any weight because I'm doing two trials with this same amount of weight. So then I can take the average. That will allow me to get a more accurate result. And so then I'm doing the analysis in Logger Pro, writing everything down in my lab notebook. And finally, I'm going to move on to the next trial where I increase the force normal by increasing the amount of weight sitting on top. And that is a little bit what the experiment is going to look like. Feel free to rewind and watch that again. A couple of things that I really want to highlight about what I did is I did those two trials for accuracy, but I also, you want to pull really gently and only record, and you can stop right away as soon as you start seeing it move. Because we really only want the amount of friction we only want to pull as hard as only to barely overcome the friction, and you don't really want to yank it or pull it very hard because then you're going to way exceed the amount of friction. We really want to get right up to that edge and then stop. So here's what it looks like kind of on the other side. Here's what the Logger Pro looked like while I was doing that experiment. So you can see I press play, and then you can see the force goes up, 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 and oh, right there, you see where the velocity becomes not zero? That's when the object started to move. So when the object started to move is where I want to look at where the force friction reached its little peak. So right here is where the object started to move, and I can see where that translates to in my force versus time graph. You can sort of see how it lines up. When I find the right period of time in my force versus time graph, then I want to take the peak right there. That is where it started to move. So in this statistics button, which you can press the 1, 2 up at the top, you can record the maximum value. Don't forget to close it when you're done so you don't get confused from run to run. Let me go back and highlight. So for example, right here, you'll notice that I am pulling on the force sensor, but the object is still not moving. That is because the force tension is not exceeding the force friction. And so therefore the force friction could be even bigger. So you can see I make the force tension even bigger and bigger until all of a sudden we see that in the velocity versus time graph, we get a non-zero velocity. You'll see that that non-zero velocity is associated with the little spike in our force versus time graph. So we can record that spike in our force versus time graph, and you can line those up pretty easily by pressing the auto scale button, and then you see how the 4 seconds lines up with 4 seconds. So you can see that this non-zero velocity, the object is moving, so that lines up with the spike in the force versus time graph. And then you can just grab the value by highlighting the right portion, pressing the 1, 2 button to get the maximum value in this region. And that is how you can do one set of data. So now we need to set up a data table before we can collect any data. So this is going to be kind of a complicated data table, so just bear with me. It's going to have 6 columns, and you should collect at least 6 data points. But for this lab, you can easily do 8 and get really good data for that. So we're going to write down the mass. And when I say the mass, I mean the mass of the block plus all the masses of the block on top of it. So let's say if the block is 30 and we put 50 on top of it, it's going to be a total mass of 80 grams. Then we're going to want to convert that mass to kilograms so we can figure out the force normal acting on the block. Force normal is pushing up by the table on the block. And so then also, so this is going to give us our X value, the X value that we're going to graph in our graph. And then to get the Y value, the force friction, remember I said it's better if you do 2 trials so you can take the average of it. So I'll do it once, get a number, I'll do it again, get another number, and then average those. And those 2 force frictions should be pretty close to each other. They don't have to be exactly identical, but if they're within like 0.1, then you're pretty good on having close amounts of force friction. So then we have our X's and our Y's. When we have those, we can go ahead and make our graph with force normal on the X and force friction, the average value on the Y. And then we'll do interpretation for homework, which some of you may even finish in our next class by linearizing the data if necessary, drawing a line of best fit, writing the equation, and then interpreting the meaning of the slope and the vertical intercept. So we're probably going to have to talk about this at the beginning of class because as you're noticing, as we're going throughout the year, the labs are getting harder and harder and more complicated. And that's because you're getting better and better as scientists. But we're going to make sure at the beginning of class that everybody feels really comfortable and confident gathering the data for this lab. Then you're going to gather the data and analyze it as a class. Please let me know if you have any questions. But for now, this is Mr. Boltri wrapping up video 6.4 on the force friction lab. So excited to run it with you in our next class, and go Bears.